Hello, everyone. Welcome to the Probability Unit, Chapter 12. My name is Mr. Minowitz, and I'm going to be teaching you how to calculate probabilities. Now, throughout these lessons, it's going to be really important that you try the warm-ups and the explorations and the examples, and you think of the ideas, and then we'll check to see if they're correct. Probability is best learned through testing something out, making an error, and realizing it either works or it doesn't. So let's start with a warm-up. Now, whenever I give you a problem, I want you to feel comfortable pausing the video, trying it out, getting an answer, and we can check it together. So go ahead, pause this video, and when you're ready, unpause it so we can check the answers. Okay, so what is the probability of spinning this spinner and getting a 1? So I look at how many total options I have. 1, 2, 3, 4. I have 4 total options. So the total amount of outcomes is going to be my denominator. And I think of how many outcomes do I want. So in this case, it says spin a 1. So I want 1 out of 4 options. 1 out of all 4 of these is what I want. Now the second is draw a card greater than 2. So which cards are greater than 2? Maybe I circle them. Maybe I write them down and see that 2 out of my 4 cards are greater than 2. So that's my probability. And I like to simplify my fractions. And sometimes the problem will tell me to write it as a decimal or as a percent. So probability right now, I'm just going to leave most of them as fractions. Now, what is the probability of spinning a 1 and drawing a card greater than 2? So I'm now doing 2 things at once. So I got to think of how many different options can I have? I can have a spin of 1 and a pick of 1, a spin of 1 and a pick of 2, and a spin of 1 and pick of 3. Now I want to think, and I might want to list them all out. Okay, or I can count. I have 16 different options. Now, which ones are winners? Okay, spin a 1 and draw a card greater than 2. Spin a 1, draw a card greater than 2. So there's 2 options that are winners. So 2 out of 16 options are winners. Another way we can compute it is we're going to learn that we can take and multiply the probabilities if they're independent, but we don't know that yet. So right now we know that 2 out of the 16 are winners, and 2 out of 16 becomes 1/8. Okay, so right now we're only counting options. How many total events and how many events out of those total do we want? So in this case, 2 out of 16. So today we're learning about probability events, how to count events, how to learn about intersections and unions and other vocabulary words so that we understand what the problems are asking us. Now in my lessons, I like to have vocabulary. I never am offended if you pause my video and copy down the vocabulary, but these are words we're going to see. We're going to see some today in day 1 and some in day 2. So now we're doing an exploration, which is another possibility for you to try the problems, to see your thinking in action. So if you would like to pause the video, feel more than welcome, and I will always give you a second and then give you the explanation. So here's how we do this problem. You roll a fair 6-sided die. Let E represent roll the even numbers and T represent roll a 3 or a 5. And the first question says, what's the probability you roll an even number or a 3 or a 5? So as long as one of those events happens, I'm happy. So I can roll an even number, so I can roll a 2 or a 4 or a 6. And it also says I can roll a 3 or a 5. So any of those I'm happy with. So the probability that one of those events happens is 5 out of 6. Now this U symbol is called the union symbol. It means or. So as long as at least one of these 2 events happens, I'm good. Now the second question says, what's the probability you roll an even number and 3 or 5? So both have to happen at the same time. Now some of you are scratching your head and saying, well, that don't make any sense. And that's exactly right. Can't happen. So the probability of the intersection of them both happening at the same time is 0. We're going to learn that these two are called mutually exclusive events. Okay, they don't happen together. Can't be both even and odd. Can't be a 3 that's even. There's no 3 even 3s, and there's no even 5s. So sometimes something can't happen. And now we got the probability that you don't roll an even number. So I got to think of all the even numbers, and then I got to think of all the others. And in this case, even numbers are non-even numbers are called odds. So that I'd want a 1, a 3, or a 5. So 3 out of 6. And we're going to use this complement symbol. So this little symbol, okay, the apostrophe looking symbol, which means not even. And in this case, it means odd. Sometimes we just call it not even. So now we saw an example before of mutually exclusive events. So mutually exclusive events mean that the events cannot happen at the same time. You can't roll an even number and a 3. Okay, there's no even 3s. You can't roll an even and an odd. You can't roll a number that's less than 2, a number that's more than 5 at the same time. So mutually exclusive means I do one thing and can 2 different events happen. Mutually exclusive says they can't. The probability of A and B is 0. Not going to happen at the same time. There's no numbers or no events that are in both circles. Now, to figure out either or, so the probability of A or B happening, we could just add the probability of A plus the probability of B because they have no overlap. This brings us to our first vocab term, which is complement. So the complement is all of the events not in A. So the complement of A, we write A complement, so we write that little apostrophe looking symbol. And we calculate it by taking 1, which is the total probability of everything, and subtracting A to find the rest. So for example, if A had a 3/10 chance of happening, C would have 1 minus 3/10, which is 7/10 chance of happening. And all the probabilities are always going to add up to 100% or 1. Now, what happens more often than not is non-mutually exclusive events. So if they're not mutually exclusive, then there's some sort of overlap. Okay, the events can happen together, so the probability of the intersection is not 0. There is some element or multiple elements that are in the intersection. And let's look at an example to see what I mean. Let's keep E as even numbers. So E is going to be 2, 4, and 6. And F is going to be a number less than 4. So 1, 2, 3. So I like to make Venn diagrams when I do these. I like to say, okay, what's in the middle? What do they both share? In this case, they both share a 2. Now, 4 and 6 are even, but they're not less than 4. And 1 and 3 are less than 4, but they're not even. So now we have some events that are only in A or only in B, and then one event that's shared. So the probability of the intersection of both happening is 1 out of 6. Okay, 2 is the only number that's even less than 4. Now to do the union, to figure out what numbers are in E or F, what I'd probably do in this problem, instead of using this crazy formula, I would say, okay, can I list any of numbers that are even or less than 4? 1 is less than 4, 2 is even, 3 is less than 4, 4 is even, 5 is not even, 5 is not less than 4, I can't say that, and 6. So I could say that 5 out of the 6 rolls would make me happy if I said I want an even number or a number less than 4. The formula says we can add up the probability of evens, so there's 3 out of 6, plus the probability of less than 4, which is 3 out of 6, and we can subtract the only number that overlaps and still get the same 5 out of 6. But it's personal preference whether you want to use the formula or count up how many winners out of how many total. Now we're going to put this all together by doing a challenge problem. So I'd love for you to pause the video to think about this. Okay, a student made target includes two overlapping squares. So we got a yellow square and a blue square. Assume that we're going to throw a sticky ball and it's going to land somewhere on the gray, the yellow, the blue, or in the middle. Okay, we're not going to miss the target completely because that's ridiculous. Now the ball is equally likely to land anywhere in this rectangle, including the yellow, the blue, or the intersection. What's the probability that it lands on one of the colors or the intersection? So go ahead and pause the video, try it out, and when you're ready, we will go over the answer. Okay, so we are ready for this answer. So the first thing I want to know is part over whole. So how much is colored out of the entire rectangle? So I'm going to look always at the whole first. So the total area of the rectangle, okay, is length times width, which is 60 times 20, which is 1200. Now I need to figure out what part of 1200 is colored, and then we're going to do that next. So we're going to do the area of the yellow, which is 10 by 10, the area of the blue, which is 10 by 10, and we're also going to need the intersection because these two events aren't mutually exclusive. The ball can land in the middle, land in yellow and blue at the same time right in the middle. So that's 5 by 5, which is 25. So we've learned now that this is an or question. It's one or both. So the union, which we learned our formula is the area of one plus the area of another minus the intersection. So 100 plus 100 minus 25 gets us 175. So our probability of either or happening or it landing in the middle is 175 over 1200. Now your grapher will simplify that to 7 over 48, or it'll simplify it to a decimal. And depending on what the problem is asking for, we can leave our answer as an unsimplified fraction, a simplified fraction, or maybe it wants it as a decimal. So this is the first lesson in probability events. Can we figure out the part we want to happen over the total that's possible to happen? That is the intro to probability.